3D printing is a technology that allows us to do so many things, from printing flexi dragons for the neighborhood children, to statues for around the house of old dark lords, to of course practical 3D prints for around the workshop in the house that can allow us to make things better right with our own machines. But what if the big kids want to have some fun? Well, in this video, we're going to be diving into the world of mostly 3D printed RC cars, namely with a design from the company 3D Sets. Not sponsored by them, by the way. I've never been much for RC cars. The last one I remember owning was a 6-wheel drive thing in the 1990s.
Scorcher 6x6. It's red.
But recently my interest was piqued, and in this video we're going to change things. The Model 18 Reaper from 3D Sets really spoke to me. Its classic hot rod style is right up my alley. And inside of this box is the 3D printer we're going to use to build that thing. The Sovol SV06 ACE, newest 3D printer from the folks at Sovol, and thank you to them for sponsoring this video and this project. More on the printer as we go, but let's get it set up so we can start printing. This is the latest iteration of Sovol's very popular SV06 line of 3D printers, an i3 bed slingers type machine. Out of the box, we get a pre-assembled base carriage, complete with the electronics box, inside of which we have a host controller and MCU, meaning that this is a Clipper firmware-powered 3D printer, complete with built-in Wi-Fi for remote management and transfer of files to the 3D printer. And there are 2 USB ports for a webcam or whatever else you may need to connect via USB. I mentioned having USB ports so you could hook up a webcam, but you don't need to, because it actually comes with one built onto the end of the X-axis gantry. And as with the previous SV06, this is a direct drive toolhead, nice, compact, lightweight, and it has a new high flow ceramic heater element heater block for rapid heat ups and high flow rates. But that's not all of what's new. There's a strain gauge on the hot end as well for auto bed leveling and automatic Z offset as well, taking a lot of the trouble out of 3D printing. As well as this PCB toolboard mounted to the side of it for easy, simple wiring back to the main board, so it's nice and clean. That's not even close to the end of what we could talk about with this 3D printer, and we will discuss it more as we go, but let's actually just use the thing and see how well it works. First things first though, we need some filament on this so we can actually print our parts, and that's where we're gonna have to take a quick trip. Now living in the Pacific Northwest, there are some great perks, like the beautiful view out of the window. And another perk is having access to ProtoPasta right around the corner. I mentioned it many times on this channel, but if you happen to have not heard, I used to build custom cars for a living. And when I did, I built high-end ones with beautiful paint jobs on them. So I wanted to mimic that when it came to this hot rod body. The selection of filament at ProtoPasta was the first thing I thought about. They make their own materials in-house and they have a wide selection of colors I could pick from. Heck, they even make their own recyclable cardboard spools right in-house. Now, this is not an ad for ProtoPasta. They did provide this material for this project, so thank you to them for that. I just legitimately thought of them when it came to a cool color for this car. And the one we landed on for this project is Joel Telling's High 5 Blue. So let's get this material loaded up onto the roller bearing spool holder and through the filament runout sensor on this machine. I can use the 3.5-inch touchscreen on here to run a load filament macro. That ceramic heater hot end heats up quickly and I can feed in my filament to the extruder. As with any new machine that I'm tuning in on a new material, to get the best results, which I'm gonna want for this project, I need to tune them in together. Temperature tuning, pressure advance tuning, and maximum flow rate testing to push this thing to its limits. I'm happy to say that the SV06 ACE hit 25 millimeters cubed per second flow rate, and ProtoPasta HT-PLA is not a particularly high flow filament, so that's pretty solid. Of course, with our filaments tuned in, it's time to start printing things, but that means we need printable files. In this case, we have to go to 3D Sets and purchase them. They are not free, they are really high quality, and I think reasonably priced for what you get, but they're not free. Once you buy them, you can download a zip folder just full of files, from STLs for individual replacement parts, pre-sliced G-code for use on Prusa printers, and then what we're going to be using, individual 3MF plates for use on other printer setups. These 3MS are associated parts, so frame parts and suspension parts grouped together on a plate ready to be printed. And there is what can be best described as a metric whack ton of them. Parts are already in print orientation. If they require supports, the supports are already there. They're pre-built into the models, which is great, so you don't have to mess with any support settings. And some parts have additional settings, like additional infill or a brim for smaller components. Though I found in Orca Slicer, it seemed like not all of these were being registered properly. With our pile of files in hand, it's time to print, and print, and print, and print, and print, and print. And oh, how I wish that was an overstatement. There are so many print beds worth of parts, over 60 of them, that have to be run to get this done, and they call for 0.15 or sometimes 0.1 millimeter layer heights to get the quality that you want out of these parts. I also ran them at thicker walls and heavier infills on a lot of parts than the print specifications 3D Sets put forward, as I didn't really care for how thin the frames were and other components of the suspension. With all the printing involved in this project, I am behind the 8-ball and I really need this done. So it's time to add another SV06 ACE to the mix so I can get these parts printed and this project completed. This thing just launched, and the introductory price, first 500 units, is $259. Link in the description. If that's gone, the main retail price is $299, so this is seeming like a pretty great value for just under 300 bucks. Now with the help of that second SV06, we're ahead, but there's still just so much printing. We'll talk about total print time toward the end of this video, when I'm sure we're done with it all. But as a result, I did have to use my Prusa printers as well. This will give us a chance to compare print results off the Prusa printers with the SV06 ACE later in the video, because I'm sure folks are going to make that comparison. For now, let's just get to the printed parts and start assembling this thing. But wait, I'm thinking about this wrong. We still need some hard parts. It's a mostly printed RC car. RCprinter.com sent over this hardware kit for the Model 18. It comes with a brushless motor, steering servo, hardware we're going to need, the belts, bearings, and a couple extra servos we'll talk about later. I still had to buy a handful of parts, such as the shock absorbers for the suspension on this, the lithium-ion battery that powers the entire thing, the rubber that's going to meet the road. I opted for some Hoosier tires to give it a classic hot rod look, and the radio control unit to actually drive the whole thing, which also came with a receiver. I do want to say that this is not going to be a full build guide, but I do want to walk you folks through some of this just to see how it all goes together. So now we're ready for our printed parts. The frame components I printed in ProtoPasta Obsidian PLA. It's got this beautiful dark gray and sparkly look to it that I think makes great frame looking components, and it feels really solid to me too. The design of the frame uses various pockets to insert some hex nuts into and then threading into plastic. I can't really describe it, but threading into plastic on these parts, they really seem to have it dialed in that it was confidence inspiring, more so than other designs have been in the past. This component shows you some of the inbuilt supports and how easily they break off, but while still well supporting the design of the part. Once the individual components are together, completing the base frame, it really gives me a nostalgic feel to see a mini car frame sitting here on my workbench. Assembling the front suspension crossmember highlights some more of the engineering, where it slips together to reinforce the parts but also kind of key them so you can't put it together wrong. The open space in the middle of the crossmember houses the steering servo. This really fits in there nicely, but it'll be fun to change later on if you ever need to. The pivot points for the suspension and steering components are all ball joints that are 3D printed, and this is the method I've been using to assemble them, squeezing them in with my Knipex and then breaking them free with my LTT precision screwdriver, and they are greased to aid this whole process. Here is the assembled front crossmember in all its glory. Now I am using the downrider kit, which is that servo at the top. That's actually a suspension ride height adjustment that will lower or raise it depending on the servo position. The A-arms continue the kind of keyed slip over design to reinforce them and make them fairly obvious how to assemble and hold it all together nicely. Now the lower shock mount is the first place I really ran into a problem, where there's just a ton of play in there. The upper eyelet, the files come with a printed spacer, but not the lower. So I just designed up my own spacers real quick, printed them, and they filled the gaps nicely. And I present to you the assembled front suspension with that downrider servo for ride height adjustment. This is the ride height position right now, but if you turn it, it raises the upper shock eyelet points to lower the ride height. And then if you turn it again, it'll raise it back up to the ride height. Next up, we're going to assemble the rear differential. This is a rear wheel drive driven by a drive shaft rear differential. Looking at the design files, there is an open differential version that is an engineering marvel in this 3D printed design. These 3D sets files, this really highlights just how well thought out and well designed they are. There are things I might have done differently with a handful of the design characteristics of this thing, but overall, it is just mind-boggling what they've put together with this design, and you will continue to see that as we put it together. For mine, I'm putting this together with a solid locked rear differential, so both rear wheels will spin at the same rate all the time. Great for going in a straight line and a straight line only. You try to turn a corner and one wheel should be spinning at a different rate than the other to go around a corner effectively, so that means donuts are in our future. I'm aware that my inexperience with RC would indicate that that's not a good idea, but go big or go home, right? The bigger thing I want to talk about isn't necessarily the differential design, but actually the parts that I printed to go inside of it. Because I used a material you probably wouldn't have expected me to on the SV06 ACE. I used PC blend, polycarbonate, namely Prusa PC blend, and I dried it in my Sovol 2-spool dryer that I've been using a lot since moving to the Pacific Northwest. I have to dry materials here a lot more than I did in Philadelphia. Now, the open air nature of the i3 Bedslinger ACE is not necessarily my first choice for polycarbonate, but I wanted to challenge it with this. It does have a 300C hot end in it, and the bed can go to 100C, so it should be able to handle this if I can control drafts. So I hung up a moving blanket on the front of the shelving unit to cut off the airflow around the machine. Then do as I say, not as I do. Don't put a space heater in this space, but that's what I did. And I got the area up to 40 degrees Celsius, and the parts printed pretty darn well. Except for the one shaft that's the tallest component on the plate, it just didn't print well. I tried to print it a couple of times on a couple of machines and it kept having issues. It's just a tall thing with a small base, even with a brim, it's a struggle. I did get it printed though, so we can assemble this entire locked rear differential. It goes together pretty simply, and you can see when you spin it one way or the other, both spin together, and that's the way it's always going to be, for better or worse. That drops into the rear suspension cradle and mounts down to it. There are a set of rear axles that are single cardan joints that I also printed in PC blend, and then the entire rear suspension assembles very similar to the front, ending up with this entire cradle that can be installed into the frame with that downrider drop servo at the top. With that complete rear assembly, we can slide it onto the chassis and mount it up with 4 mounting screws. That will end up with a completed chassis minus the drive unit and wheels. So it's not quite a rolling chassis, but it's almost there. Now that I have this assembly here in hand, I have to stop and say, I am so impressed with the design philosophy and the entire tolerances and everything that 3D Set has put together here. I know I've said that already, but I can't overstate that. As a designer myself, I am just really impressed. Even threading into plastic, which has to happen a lot in this design, is not something I generally put into my designs. I don't care for it in the long term, for serviceability especially, but they just have it at a point where it fits just right that I'm not worried about it stripping out, and it goes in easy enough to not really be a problem. It's just really well designed. Now we just need what's going to actually drive the rear wheels on this thing, the motor and the belting gear reduction setup that's going in here. This design really speaks to the engineering going on in here. We start at the tail shaft and build our way forward. There's an extension shaft to make it like a regular tail shaft of a transmission. Then there's 3 separate belts inside of here, each one being a stage of gear reduction in the gearbox. The housing sections have pressed in bearings that fit really well into these parts. Then there's cogged pulleys that press into those bearings. Each section sandwiches the previous one together and provides the double shear support for each of the cogged gear shafts. There are little access windows in each of the stages to help you line up the belts onto the pulleys as you put them in, and then finally you get the motor installed on the front of the housing. I didn't see the gear ratio of this gearbox listed, so I just wanted to see what I could figure out. I put a mark on the motor and then I just started turning the output shaft. As best as I can count, it's somewhere around 4 3/4 to 1 gear ratio through this thing. There's a gearbox mount crossmember that mounts to that back tail shaft housing, and then it slips into the chassis to produce now our pretty complete rolling chassis, which means it's time to move on to the body parts and get this thing looking like it's supposed to. Now the body is where we're gonna highlight 1 or 2 things I don't love about the 3D set designs. Don't get me wrong, they're exquisitely designed with inbuilt supports on a lot of the parts. Like I said earlier, when you need them, they're already there. But you can see I added some additional support to this piece. I felt that it could just a little bit use that, but it was also to stabilize the print. I also added a brim all the way around this part because an earlier attempt at this part failed. It got knocked off of the print bed when I only used mouse ears on it. The print file, at least when it imported for me into Orca Slicer, did not have a brim on it. And it's only this bottom edge here that sits on the bed, and that's all that holds it in place while it prints its way up. This is something I kept noticing with the body files. Some of them have far less in contact with the bed than that, where there's just this little sliver on the bed and it's gonna be easy for a printer to knock the print off. This is just where paying attention to your slicer settings can really pay off. I was able to get a full set of printed parts out and ready to go and start assembling the cab. From the floor, the rear wall, the firewall, and the cowl area, we build our way up. However, before we continue, we have to install the ESC and the receiver into the floor, as there's pockets they fit into. I did run into a problem here though. I need an XT connector on my ESC to connect to my battery. So luckily I had one in inventory that I could solder on and replace the connector that was on there before we install the roof. Which I feel like this is probably a pretty good time for us to do the print quality comparison between the Prusa Mark IV S and the SV06 ACE. Because this roof piece for the body, I printed 3 times in total to get the quality results that I wanted. Part of that was down to just how little of this part is in contact with the print bed while it's printing. And this one was printed on the Mark IV S, and it was kind of wobbling toward the end of the print, which caused some print quality issues up toward the top of it. It's fairly tall for how little is in contact with the print bed. Now for one of the ones from the Sovol, I added some additional tree support on the inside of the roof, as well as the back side of the roof where it comes down to meet the back wall. I did that just for stability. I didn't feel the part needed additional support to support the material. I needed it to support it from wobbling. There's a little quick tip for you. Supports can be more than just supports. They can be additional adhesion. If you have a part that has a small contact patch, a little extra material in there can help to hold the print to the bed, and it can also help to hold it to the bed when the part wants to wobble a little bit to help stabilize it. Looking at both of these parts side by side, printed in the same material using very, very similar settings, speed varied between the two, and of course, slight filament tuning differences for the 2 different machines, I would say the Mark IV S is slightly better. There's a little bit of VFA and maybe a slight bit of Z inconsistency on the part printed on the SV06 ACE. But to tell you the truth, I have to look at it at an off angle and really get it under my light here to see that. I already did say that I feel the print quality off the Mark IV S is slightly better. There's a little bit less VFA, a little more consistency in the extrusion, but it's also 2.5 times as expensive as the SV06 ACE. So it's really gonna have to be up to you whether or not this quality off the ACE is good enough for what you're paying. And I think it's a pretty good value from what I'm seeing. Comparison over, let's get back to assembling the body on this thing. I don't want to get too bogged down in the rest of the body assembly, as it's a lot of rinse and repeat, follow the instructions. But I do love the details they've added, like you use transparent foil for the windows all around it. The dashboard has gauges that are printed with changing colors at certain heights to get this effect. There's a glove box, there's a steering wheel, there's bomber seats, and the seat base that they sit on covers over top of that ESC and that receiver the electronics that we've already installed, so it hides them away and finishes off the look of the interior. They don't have to do this stuff, but they do, and I appreciate the level of detail that they put in. It's also just well thought out. The battery connector comes through the back of the cab to where the battery will be. There's a little hole for wires to pass through. There's even an engine that is just a cover for the motor, so you see it under the hood, but you don't have to see the motor anymore. I printed the engine block in candy apple red from ProtoPasta. All the silver accent pieces around the build I used their second to none metallic silver for. The last detail I want to point out is even the wheels are 3D printed on this project. They are a split rim design, so they're two halves that you bolt together and they sandwich the tire in between them, but they're not a bead lock, which will come back up. And with that, we have the Model 18 Reaper, the first RC car built in the Mandic Labs. Now I will say, I've already filmed the B-roll beauty shots of this thing. We will take a closer look at this thing, but first I want to get it out into the real world and see what it can do. I filmed the beauty shots ahead of time because I have no idea what I'm doing, so we need to make sure that I don't crash it, or if I crash it, I at least have the shots for you folks to see it closer before we're done. So let's get out into the real world and get some action shots. Okay, I'm out here, I'm a bit out of breath. I've been running, trying to create a forced perspective thumbnail image for this video that I don't think is gonna work out. Maybe you saw it before you saw this video, I don't know. It's a typical rainy fall day here in the Pacific Northwest. There's a slick on the ground, so this is gonna be extra interesting, especially with that locked rear differential and the birds screaming in the background. I hope any of this turns out worth a damn. Otherwise, you're just gonna get footage of this thing spinning around. Let's see. I am out of shape. I'm a YouTuber who works in a lab. Let's see what happens when I pull the trigger. The one front tire almost immediately folded off the bead when I was trying to run it around a circle pretty hard, telling me that they're just not gripping hard enough, which I expected. The rear rim, the way it's designed, has like a taper to it to make it more printable, the rear half of the split rim. That kind of allows the bead of the tire to just ramp right up off of it. Not the greatest. You could probably hear the remote control throwing a low battery warning at me, but the battery was freshly charged and showing 7.6 volts before I started the run, but when I'm steering and powering at the same time, it draws too much power, it seems like. So this thing is like way underpowered from what I expected it to be. Don't know if that's just the way it is or down to the battery. Almost immediately, again, one of the front tires ramped off of the rim. It just has no chance to stay on there. It just slides right off the back. It's this front left one both times. The right one's still on there pretty good. Let's do a drive-by with this thing running down the road at full tilt, which honestly is not an impressive speed, and then head back to the studio to check it out. Successful maiden voyage out of the way, largely successful. Let's talk about the final details of this thing. Some of the things I might have glossed over, total print times, and my real thoughts after building the Model 18 Reaper for myself. First and foremost, I know that a lot of the build process I glossed over. I really just wanted to present you the design philosophy and some of the key points about how things go together. I didn't want this to get bogged down as a full build guide. That would have made this a much longer video. I hope I conveyed the assembly process in a way you can understand. The instructions that come with this whole setup are excellent. They're Lego-esque, where you get a picture, it points to where the screw needs to be installed, where the part needs to be installed. It's not 100% clear, just like Lego sometimes, exactly where things go, but the basic concept of it really does work well, especially if you're familiar with that type of instruction set. The only issue I ran into with them was the Downrider pack. That is an add-on to the base Model 18. You have to buy that in addition to the base files, and it adds those ride height adjustment servos and some aesthetic touches. You would reach a point in the instructions where it would say, if you're doing the Downrider, go to those dedicated instructions for that. They didn't feel cohesive in multiple ways. The biggest of which was the bed assembly on this thing. They have you assemble the bed off of the truck and then install it onto here. Except with the Downrider pack, it hits the servo and you can't do that. But they still tell you to do it that way. It felt like nobody had actually ever installed it with the Downrider pack when they wrote the instructions. I would have preferred to see just a dedicated Downrider instruction set. It didn't feel like it would be that out of the realm for them to just have two separate sets of instructions that would integrate all of that more seamlessly. We might as well continue with a few of the negatives that I ran into. Overall, the part design and the assembly is excellent, but there are a few elements that kind of feel like they just finished them and walked away toward the end. Like, there's a keg in the bed that's supposed to be in the fuel tank. It hides the servo motor for the rear suspension adjustment, but it just kind of clips down onto a couple of tabs. It's somewhat securely on there, but it absolutely wiggles around, and I would be afraid in a rollover it would just go launching off into the distance. At least one retaining screw in that sure would be nice. Those front wheels that just aren't keeping the tires in place, I don't really know what to say about that. I might attempt tackling a redesign of these to get them to work better, but all I have is STLs to work off of, and that's not a fun process. Next up is the bill of materials, the BOM. You're gonna need additional parts for this. It's not 100% 3D printed. And when I walked into the local hobby shop with that parts list and handed it to them, because I, as a first-time RC builder, didn't know what half the stuff was, they were kind of confused by some of the specs too. I'm not sure where 3D Sets is located, but it felt like when I was Googling or going on Amazon, putting in the information they had on the BOM, looking for servo motors or batteries, it was kind of vague and it was pointing me to a million different options and I wasn't sure at all what to get. I ended up going to their Facebook group to figure out what servo motors I needed for the Downrider ride height adjustment, and the ones I ended up getting were ones recommended in that group, and I think they're too weak. I barely get any ride height adjustment, and they're not turning as far as I think they should. Now again, rcprinter.com, thank you to them, they provided a lot of the parts for this. When they sent me the parts kit, they sent me servos that they quickly realized were way too weak for this application, and they said don't even bother using them. They do have now stronger ones that are rated higher than the motors that I have here, so they should be able to help you out with this, and at least a company like that exists to help folks like me who don't know what they're doing. Along those lines of my inexperience, maybe you already know what's going on, what I'm missing about this, but I expected this thing to be a lot more powerful than it is. They were warning about donuts with the locked differential. I'm just getting skipping tires as I go around corners. It doesn't have enough power to actually kick out the rear on wet pavement. The motor provided by rcprinter.com is a 3630 1400 kilovolt motor. I assume that's power rating information. I have no idea, and the information I could find online was not very helpful. I don't know if putting a bigger battery with a little more voltage in would make a big difference. Let me know in the comments if you're into RC stuff, what you think I should do to pep this thing up a bit. But of course, this is a mostly printed project. So what about that portion of it? How was that whole thing? Quite honestly, I had a blast putting this thing together, printing the parts. It was quite stressful for me, we'll talk about that, but for the most part, it just made me nostalgic for building cars, where I would be putting components together and looking at how I would get better gaps if I really wanted to sand edges and put some time into it the way I would building the cars I used to build. I couldn't do that, and especially would be difficult on printed parts to get the best finish doing that, but it was fun all the same. The stressful portion of this is down to me, my obligations. I've got to get videos out fairly quickly, and this really took a lot longer than I had hoped it would. I wanted this project done days ago. Now, the total print time using 5 machines took 293 hours and 43 minutes of printer time. Mind you, some of those are doubles or even triples, where I printed parts a couple times to either get the exact quality that I wanted, where I had bad slicer settings or failures, or I printed a couple of parts multiple times just to compare the results off of different machines too. That's not accounting for the bulk of that time, but it is some of that time. Also remember that I printed the majority of these parts at totally different slicer parameters than they recommended. Most of the parts they had like 2 walls and 10% infill, and a lot of them I felt that was just way too light. Like the frame components, I'm pretty sure I'm at like 4 walls and like 40% infill on all of those parts. The body, I'm more like 3 and 20% infill. So I made these parts a lot heftier, and that's probably weighing this thing down just a little bit more than they recommended too. Overall, I have had a great time building this thing. Some minor frustrations, mostly down to my time management skills, but overall, it's been a good time, and I can really see some of the appeal in this whole process for a lot of folks. It's a great way to take your 3D printers and do something that isn't just building 3D printers, which is often what I end up doing. The SV06 ACE, thank you again to Sovol for sponsoring this video, was reliable. I ran this machine the most on this project. Well over 150 hours of the total print time was just on the SV06 ACE for this, so the bulk of the printing was done on that machine, and it didn't give me any trouble beyond print failures that I can't blame on the machine. If you're interested in checking out the SV06 ACE, there will be a link in the description to where you can pick this up for yourself and your printing projects. All right, folks, that's where we're going to wrap it up for this one. I hope you found this project interesting. If you have input on how I could improve this build, stronger motors, better battery, whatever, let me know in the comments. I would love to hear it. I'm going to leave you with a little bit of pretty B-roll from this build, showing you the final result of it. So be sure to get subscribed to ensure your 3D prints don't fail. It's not a guarantee, but it can't hurt. See you, folks.